Okay, so we're going to work on two problems today, and one is going to be function composition, the other is going to be finding a difference quotient, which is actually related to it. Now, the first thing we're going to do is we're going to start out with the function f of x is equal to 9x minus 7, and g of x is equal to x plus 9 divided by 7. Now what we want to find is f of g of x. So essentially what we're going to do is anywhere, so if we look at f of x, right, anywhere we see an x we're going to replace by x plus 9 over 7. So what this is going to be do is you can see here we have an x and here we have a g of x. So it means we're going to take out the x from this expression and we're going to plug in g of x, which is this. So it's going to be 9 times g of x, which is x plus 9 divided by 7, minus 7. Now, because this is a fraction, I want to write 9 as a fraction, 9 over 1. So this is going to be equal to 9 times x plus 9, because when I do multiplication of fractions, I just multiply the denominators across and multiply the numerators across. So this is going to be 9 times x plus 9. And the denominator is 1 times 7 is 7. And it's going to be minus 7. But I want common denominators, and I want to work with fractions in the first place. So I'm going to write 7 as 7 over 1. Now this has a denominator of 7, this has a denominator of 1. So I'm going to multiply the numerator by 7 and the denominator by 7. I can do that because 7 divided by 7 is of course 1. Then multiplying the numerators across, the numerator is going to be 7 times 7 is 49. The denominator is going to be 7 times 1 is 7. So this is going to be equal to 9 times x plus 9 divided by 7 minus 49 divided by 7. And this is going to equal, next I'm going to use the distributive property. And I'm going to do 9 times x is going to be 9x. Multiplying the 9 to the x. Now using the distributive property to distribute the 9, it would be 9 times 9 is 81. Divided by 7. Minus 49 divided by 7. Now, because I have common denominators, I can add the numerators. And this is going to be 9x plus 81 minus 49 divided by 7. So what is this going to equal to? Well, 49 in 1, it gives me 50. And if I add another 30, I'm up to 80. And if I add another one, it gives me 81. So 81 minus 49 is 32. So this is going to be equal to 9x plus 32 divided by 7, and that's my answer. Okay, so I hope that answered the question that was asked. And just the answer is, if this is f of x and this is g of x, what is f composed with g of x? Okay. So the other way we could do it is we can do g composed with f of x. And to do g composed with f of x, again we have g of x is equal to x plus 9 divided by 7. And f of x is equal to 9x minus 7. Now, g composed with f of x is going to be the other way around. Anywhere I see an x, I'm going to replace it by f of x. Well, f of x is 9x minus 7. So instead of x plus 9, I'm going to write 9x minus 7. So instead of x, I'm going to put 9x minus 7. And then it's going to be plus 9 divided by 7. Well, when I have these parentheses here, I can think of just having a 1 outside the parentheses. And I can do 1 times 9x using the distributive property is just 9x. And a 1 times a minus 7 is just a minus 7. So it's going to be plus 9 divided by 7. And a negative 7 and a positive 9 is going to be a positive 2. So this is going to be equal to 9x plus 2 divided by 7. And that's my answer for this question. Now, the next thing we're going to do is we're going to work on a difference quotient problem. Now, we want to find the difference quotient for the function f of x is equal to x squared plus 4x plus 6. Now, the first thing we're going to do is do f of x plus h is going to be equal to x plus h, quantity squared, plus 4 times x plus h, plus 6. So why did I do that? Same thing with function composition. Here I'm swapping the x with x plus h. So here I have an x squared. Here I have an x plus h squared because I'm using x plus h. Here I have a 4 times x. Here, because I'm swapping x with x plus h, I have a 4 times x plus h. There's no x's here, so these are just 6's. And then what I'm going to do is I'm going to square this out. So if I do x plus h squared, this is going to be x squared plus 2xh plus h squared. Then I multiply this out, and 4 times x is going to be 4x, and 4 times h is going to be plus 4h, and then I have plus 6. Okay? So if you remember, the difference quotient, I'll write on a separate piece of paper, is just going to be, the difference quotient d is going to be f of x plus h minus f of x divided by h. So I found f of x plus h, and I know f of x, so I'm going to subtract them now. So this is f of x plus h, and what I'm going to do is I'm going to subtract f of x. So I'm going to do minus x squared plus 4x plus 6, right? So if I distribute the minus sign, I put the minus sign in front of the whole parentheses because I'm subtracting the entire expression. So I'm going to rewrite this. I'm just going to rewrite the first term, f of x plus h, is equal to x squared plus 2xh plus h squared plus 4x plus 4h plus 6. That should be an h, sorry. And over here I'm going to have minus x squared, because I'm distributing the minus sign to each of these. I'm going to have a minus 4x, and I'm going to have a minus 6. So these terms cancel, these terms cancel, and these terms cancel. And I am left with, okay, and I just subtracted, I just recopied this over here, f of x plus h minus f of x. I just distribute the minus sign to f of x. So I'm left with f of x plus h minus f of x is going to be equal to 2xh plus h squared plus 4h. And to get the difference quotient, I'm going to divide everything by h. And that's the difference quotient, but I can simplify it. I can simplify it because each of these three terms has an h. So I can factor the h out, and I can write it as h times 2x plus h plus 4 all over h. Now, I have a number times this parentheses, which is another number. So whenever I have multiplication over division, I can cancel. And I'm left with 2x plus h plus 4. And this is the answer. And the whole reason for the difference quotient is essentially gives us the average rate of change between the points x and x plus h. And if you let h go to 0, then you wind up with the average rate of change between x and x plus h. Then they're the same point if h is 0, so you wind up with the instantaneous rate of change, which brings you into the topic of calculus. So that's kind of the stepping stone there. And that's how you solve this problem. So I hope that answered your question. And please feel free to ask any others. Thank you, and I hope you have a great day.